everybody, welcome to my channel. Today we have a very good problem for you guys. We're talking about leaf similar trees, right? So this is a very good problem, so make sure you pay close attention to the problem statement, right? So it says consider all the leaves of a binary tree, right? From left to right, the values of those leaves form a leaf value sequence, right? So like you can see, we're given this binary tree, and the leaf the leaf, like the leaf nodes, right, they form some sort of a sequence, right? I know, from left to right, right, like they're saying, and the sequence is 6 7 4 9 8, right, for this particular binary tree, right? Go from left to right, which is how it would be, we would see them, right? 6 7, right, 4 9 8, right, so 6 7 4 9 8, right? So it is, right? So it says, for example, the given, this is what I just went through, right? This is what this binary tree is, the leaf value sequence, right, of this binary tree, right? 6 7 4 9 8. Okay, it says two binary trees are considered leaf similar if their value sequence is the same, right? So two binary trees are leaf similar if they have the same value sequence, right? So the binary tree can be structured differently, right? But if their sequence value, right, of their leaf nodes, right, are the same, then we can call them leaf similar, right? So return true if and only if the two given trees with head nodes of root 1 and root 2 are leaf similar, right? So it's kind of what the ask is to do, right? Given two binary trees, find out, right, if they have the same leaf value sequence, right? That's kind of what this problem is, right? If they have the same leaf value sequence, then we can say that we can call them leaf similar, right? Okay. So this example is going to help us to solidify the ask, right? So this binary tree, right, first one has a leaf sequence value of 6 7 4 9 8, right? Because that's why we're reading it from left to right, right? It's kind of what's important, right? And then the same thing we do here, right? 6 7 4 9 8, right? Just like that. And for this one, right, for this, we can see that it's different. They don't have the same value sequence because 2 3 is not equal to 3 2, right? Even though they have the same numbers in there, right? But they're not in the right sequence, right? So it doesn't work out. So we'll return false here right away, guys, right? Because the sequence matters as well, right? It needs to be the exact same order, right? Reading from left to right, right? Yeah, it needs to be the exact same order, guys, right? So how do we go ahead and solve this, guys, right? What do we need to do, right? So we know that we need to do some sort of traversal, right? We need to traverse the tree somehow, right? And what we need to do is to maybe capture the leaf nodes, right? Capture the leaf nodes and then compare them, right, with each other, right? Because I'm thinking about the straightforward way of doing things, right? We need to capture them and then compare them, right? Easy like that, right? But what kind of traversal do you need to do, right, to capture it in the order that they want, guys, right? They wanted to read it from left to right, right? From left to right, 6 7 4 9 8, right? Not 6 9 8 7 4, right? It doesn't work like that, right? It's not a layer by layer thing, right? So from left to right as we're going, right? So layer by layer wouldn't work because it doesn't give us the order that we want, right? From left to right, right? It would be ideal. It would be good for the case where we wanted to have like a layer by layer thing, right? Capture leaf nodes layer by layer, right? But they want the nodes to be captured from a left to right type of thing, right? So the layer by layer thing won't work here, right? So what I'm thinking here is we're left with depth first search here, right? So this is like what we're gonna do. We're gonna do a depth first search, visit the nodes as we visit the leaf nodes, right? So we're gonna visit the left nodes first, right? The left subtrees first, and then we visit the right subtrees, right? So that way we can capture the leaf nodes in the order that they want, right, from left to right, right? So we only gonna visit the right subtree when we're done visiting the left subtrees, right? So that's how we're gonna do, right? So as we traverse, if we encounter a leaf node, we put it in the list, right? So we're gonna have a list to capture all the leaf nodes, right? From one another list to capture all the nodes from the second binary tree, and then at the end, right, we just do a comparison, right? To see if every value is in the right sequence as the other one, right? So if they're exactly at the same, right, they're the same size, they have the same value at every index, then we can conclude that they must be leaf similar, right? Since the numbers are on the right sequence, right, and they have the same set of numbers, right? So it kind of works out. So it's kind of how the old algorithm is going to work, guys, right? So hopefully you guys were able to understand the thought process, and hopefully it made sense. The explanation, if it didn't, let me know in the comment section, and next time I can do a little bit better at explaining it. So let's quickly go ahead into it, guys, right? So what I'm thinking here, so what I'm gonna do is we're gonna have a list, right? To capture, like I said, guys, right? Capture the display leaves, right? One. Okay. I don't know why I keep doing that. Okay. So we got this leaf, then we're gonna capture this. We got this second leaf, right? Leaves two to capture all the leaf nodes from root two, right? You know, so and all the leaves one is gonna capture all the leaf nodes from root one, right? So let's continue. Then we're gonna have to call this function. Right? This function we're gonna pass in the root nodes, so each one, right? So it's gonna capture all the leaves, right, from root one, and all the leaves from two, right? Then at the end, right, you know, we could either do it ourselves, right, you know, compare make sure they're the same size, they have the same set of numbers, and also they're in the right sequence, right? So pretty much all we need to do is to check for every index, does, you know, the number at this particular index equal to the same number as the number that's in the from the two lists, right, if they're the same, right? So index 0 and in both lists, do they have the same number? So that way we can kind of compare the same, like they have the same numbers, right? That we expect, right? So if they have the same thing, if they differ at any index, right, then we know that they're not at least similar, right? Because in the order that we capture them means that, you know, yeah, it's different. Okay. So even though, like, you know, for by the tree, right, for it to be, you know, leaf similar, right, even though it can be structured the same, but the sequence of the leaf, right, leaf nodes, right, needs to be the same, right? So at the end, we're gonna check leaves one that equals, right, to leaves two, right? Looks good so far. So all what's left for us to do now is to do the hard part, right? Not really hard, but you know, it should be pretty simple. So we're gonna do a simple differ search, guys, right? So what we said we will take in a root node and also a list of integers, right? Which are the leaves values, right? That's what we care about, okay? So now what we're gonna need to do is to check, right? If you know, the simple check that we always do, if the root is null, simply just return. Need to look to do anything any further. So and then we're gonna check here, guys, right? If the thing is a leaf node, right? So we know the thing is a leaf node if the left no child's null and the right child's null as well, right? Then we just do leaves that add root that val, right? Add that value in there. And it would just simply return, right? I'm a leaf node. I don't need to, I have no children, right? So there's no need to go further, right? But if I'm not a leaf node, then I'm going to continue. Like I said, we're going to visit the left side first, right? That's what we're going to do. So we're going to pass in the left side and then pass in the leaves, right? So that they can do the same thing. Then we just copy and paste the same thing, you know, save time. This time we're going to pass in the right, right here. Okay. All right. So what's next for us here is to, yeah, we pass in the root two as well. Okay. So we get two leaves, right? So two lists to capture the two, like all the leaf nodes, right? From root one, root two, respectively, right? So, and then we compare the two lists, right? If they're the same values, right? In the same order, then we can just say they are equal to each other, right? They're leaf similar, and press submit. Awesome, guys. We're able to pass all the test cases, guys. If you guys found value, you guys understood the thought process and the explanation in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.